another very common type of question is like this. We have a statue on top of a pedestal. Okay, so let us say that AB is our pedestal and there is a statue on top of it. So from B there is a statue BC, which is our statue. We will be given information like this, that from a point on the ground, now obviously the pedestal is the thing that is on the ground. From a point on the ground, the angles of elevation to the top of the pedestal and the top of the statue are, let's say, 30 degrees and 45 degrees respectively. Along with this, we will be given one length, either the distance between the point and the pedestal, the height of the pedestal, the height of the statue, or perhaps the height of the point C above the ground. Let's say in this case, they give us the height of the pedestal. So they say that the pedestal is 3 meters tall. And they ask us, find the height of the statue. Now when they say height of the statue, they mean BC. They don't mean AC. They want only the height of the statue itself. Statue has been placed on a pedestal, which is why it's become higher, but the statue itself is simply BC. So the question is, find BC. Now once again, what we need to do is, we need to think of what are the triangles available to us. Now obviously this is going to be a right angle, because again it's a pedestal standing on the ground. So the two right angle triangles I have are DAB and DAC. I do not have a right angle triangle with just BC. DBC is not a right angle triangle. So like the Banks question, we need to think and be clever that okay, BC can be calculated as AC minus AB. And the reason we do that is, well, we already know AB, and if I can find AC, which should be possible since it's a right angle triangle, then I'll simply subtract and get my answer. So let's do it like that. Now, to find AC, I need to know at least either AD or DC, because that is the only way I'll be able to relate it. So we have to think of a way to either find DC or find AD. Now DC can't be found in any way. There's nothing else known in that triangle. However, in triangle BAD, I can find AD because I know BA and I know angle D. So just like in the previous question, I know my height or my perpendicular, I need my base, so I will use tan. So tan 30 degrees, which is the angle of D in triangle BDA, is equal to AB upon AD, which means AD is nothing but again 3, which is the height of AB, divided by 1 by root 3, the value of tan 30, which again becomes 3 root 3 meters. So now I have AD. Now I can get the length AC from triangle CAD by again doing tan, this time 45, because in triangle CDA this is 45 degrees. So tan 45 is equal to AC upon AD. Once again, tan 45 is just 1. AC is what I want to find. AD we have calculated 3 root 3, which gives us that AC is equal to 3 root 3 meters. And finally, the final goal was to find height of the statue, BC, AC minus AB, which means BC is equal to 3 root 3 minus 3, because that is already given, which is 3 into root 3 minus 1 meters. So once again, determine the triangles we can use, figure out exactly how to calculate what we need to calculate, and then determine the angles and the function that we need to use. So like I said, this question can come in many different ways. They could give you this length, they could give you BC, they could give you AC. You will approach it in the same way. You always find your AC, AB and then calculate from there. So this is another standard type of question. There are a couple more, so let's look at them now. Now the next question is one in which you need to very carefully listen to what the question is saying. Now in this case, the question says that a building and a tower are on opposite sides of a street. Before I draw the figure, I'm going to finish the question. It says the angle of elevation of the top of the tower from the bottom of the building is 60 degrees and the angle of depression of the top of the building from the bottom of the tower is 45 degrees. So be very careful by what they said. So it says the angle of elevation from the bottom of the building to the top of the tower is 60 degrees, which means if I assume that my building and tower are like this, again, they're on opposite sides of a street, obviously they are straight. Let this be our building and this be our tower. So the angle of elevation of the top of the tower from the bottom of the building is 60 degrees. The angle of depression of the top of the building and the bottom of the tower is 45 degrees. Angle of depression means I need to create a parallel and get it here. So notice how I drew my figure. After drawing the building and the tower, I simply focused on what are the 2 points I'm concerned with. Bottom of the building, top of the tower, join it. Then it says angle of elevation. So over here, top of the building, bottom of the tower, join it. Angle of depression, up here. That is how to tackle questions like this. We're also told that our building is 50 meters tall. We have been asked to find the width of the street and the height of the tower. So we have to find width of the street, BD, height of the tower, DC. Now, like in the previous questions, we identify our triangles and we start working with it. Now, I know the length AB, so I know the height AB. Let's first look at the street width. I need to find BD, which is the width of the street. So in triangle ABD, full angle B is of course 90 degrees because it's a straight building. So with this being a right angle triangle, again, if I can somehow find this angle, I can use tan to get my height and my base. And I can get this angle. My angle of depression is 45 degrees. Alternate interior angles. This becomes 45 degrees. So in triangle ABD, tan 45 degrees will be equal to AB perpendicular upon BD base. So again, 1 is equal to 50 upon BD, which means BD is 50 meters. So we have solved the first part of our question. We have obtained the width of the street. Now the benefit of this was, now that I know the width of my street, from triangle CDB, I can find the height of my tower. I know this angle. This is again perpendicular base. So tan 60 in triangle CDB tan 60 degrees is CD upon BD. 60 tan 60 is nothing but root 3 is equal to CD, and BD, which we've just calculated, is 50, which means the height of the tower CD is 50 root 3 meters. So once again, all we needed to know is what do I need to find, determine my triangles, and move on from there. Here we learned how to tackle complicated questions when we're not very sure about what angle is where. So just keep your 2 points in mind, draw the line of sight, and then if it's elevation, it's at the bottom. If it's depression, it's at the top. So like this, you can tackle these questions. So just a couple more, and then you should be prepared to tackle this chapter. Now another question which is fairly straightforward once you determine the triangles involved. So we are told that there is an 80-meter high lighthouse. So an 80-meter high lighthouse. And that there are two ships, one behind the other, on one side of the lighthouse. Now a lighthouse is of course nothing but something that stands on an island, and its job is to warn ships that you are near the island. So there are two ships right behind each other. So let one ship be A over here and another ship be B over here. We are told that the angles of depression to both the ships is 45 degrees and 30 degrees respectively. Now here you need to use a little bit of logic to determine which is 45 and which is 30. Now by looking at the figure, it's quite clear. Now we're talking about angular depression, so I create my parallel. It's quite clear that this angle is bigger than this angle. Therefore, this is the one that is 30 degrees. Let it be OP and this be some other point C. So CPB is 30 degrees and CPA is 45 degrees. Now the final question is find the distance between the two ships. In other words, we have to find the distance AB. Now, like in the pedestal question, AB does not form a right angle triangle with anything. PAB is not a right angle triangle. However, AB can be done with OB minus OA, and those two are parts of a right angle triangle. So that is exactly what we're going to do. We're going to say that AB is nothing but OB minus OA, and then we're going to jump into our triangles. So again, if angle CPA is 45, by alternate interior angles, angle PAO is also 45, and so in triangle PAO, once again tan 45, and you'll slowly become very used to this. I know my perpendicular, the height of the lighthouse. I need my base OA. So tan 45 is OP upon OA. Once again we get 1 is equal to OP upon OA, which means OP is equal to, which means OA is equal to OP, which is nothing but 80 meters. Similarly, in triangle POB, now this is going to be 30 degrees because CPB and PBO are alternate interior. So tan 30 degrees is equal to OP upon OB, which means 1 by root 3 is equal to 80 upon OB, which means OB is equal to 80 root 3 meters. And so finally, the distance between the ships AB is equal to OB minus OA, which is 80 root 3 minus 80, or 80 into root 3 minus 1 meters. So once again, what we learned new in this question is how to, with logic, determine the value of the angles. That yes, this just by looking at the figure is obviously bigger, and therefore this will be 45, this will be 30. And the rest of it was just like previous questions, where we identify what do we need to find and proceed to find it. So let's move on to the last question, which is a slightly more challenging question from a calculation perspective. Now in this final question, you are going to feel like there is not enough information, that how can we solve this question? But we will do it in a clever way in which you will be able to see that there is actually enough information. So the question says there is a tower, and from the top of the tower someone observes a car at an angle of depression of 60 degrees on the road to the foot of the tower. So someone observes that of 30 degrees, not 60 degrees, of 30 degrees to the foot of the tower. After 6 seconds, they observe that the angle of depression to the car has now become 60 degrees. Also logical, we can see the angle is increasing. The question asks, how long will the car take to reach the foot of the tower? So like I said, we've not been given the height of the tower, we've not been given any of these distances. This is all the information we have. So here you will use a small topic in physics to solve this question. If you remember, distance is nothing but speed into time. And so let us assume that the car is moving at a speed s. Then the distance it covers from A to B in 6 seconds is 6s, because distance is speed into time. And using this, we will solve the question. Now, there are 2 missing distances in this question. The height of the tower, let it be y, and this distance x, which is BC. So effectively, if I'm able to find the distance BC, then I will divide it with my speed, and that will give me the time. So I need to find BC. So let's do that. Alternate interior angles, this is 30, this is 60. Let's create our equations. In triangle OCB, tan 30 degrees is equal to OC upon AC. Tan 30 is 1 by root 3, which is equal to OC, which is y, upon AC, which is nothing but AB plus BC, 6s plus x. So we end up getting an equation 6s plus x is equal to root 3y. Let us leave this over here. In triangle OCB, tan 60 degrees is OC upon BC. Tan 60 is root 3 is equal to OC, which is y, upon BC, which is x, which gives us y is equal to root 3x. As I said, we simply need to find the value of x. Let us substitute the value of y into the first equation. We will end up getting 6s plus x is equal to root 3 into root 3x. Root 3 into root 3 is nothing but 3x. We end up getting 6s plus x is equal to 3x. We will shift. We see that x comes out to be 3s, because obviously this will become 6s is equal to 2x. 2 and 6 will cut. We are left with x is equal to 3s. Now that I know my distance x, like I said, time is distance upon speed. So time taken, let us do it over here, will be distance upon speed, and we know that the speed is s, which is nothing but 3 seconds. So this question shows us that even if we don't have the exact values, by referring to things in terms of assumed values and by creating linear equations, we are able to solve questions as well. So this is how you would solve a question like this, and where you need to apply these kinds of concepts. This is of course a very unique question, but the linear equation part is actually very useful. Let's say hypothetically, instead of it being something like this, they told you the length AB. This shows you how you could solve the question by using linear equations to get BC, OC, and so on and so forth. So with that, the chapter is primarily over. These are the different types of questions you will encounter. So you just need to practice them, get comfortable with the triangles, the angles, and go from there.